Now in example 3, it says match the function with one of the following equivalent expressions, then confirm the match with a proof. The way we're going to do that, we're going to take out our graphic calculator. So 1 divided by 1 over cosine of x minus 1 plus 1 divided by 1 over cosine of x plus 1. Then what we'll do, we'll have, for 2 cotangent of x, cosecant of x, we'll have 2 divided by tangent of x. Let's put these both in parentheses here. Tangent of x times sine of x. We'll see which one matches. Window, we can go negative 2 pi to 2 pi. And negative 4 to 4 should be sufficient. Here's our first equation. Let's see if this one I just put in matches it. Look at that, it does. Okay. So it looks like our first option here matches. Now what we're going to have to do, we're going to have to confirm it with the proof. Well, so this is, we're going to try and get this side equal to this. To do that, we're going to add the fractions. So we'll have 1 times secant x plus 1 plus 1 times secant x minus 1. All of that over secant x minus 1 times secant x plus 1. When you simplify this, we'll have secant x plus 1 plus secant x minus 1, which means we'll have 2 secant x on top over secant squared x minus 1. From our Pythagorean identities, we can see that secant squared x minus 1 is actually equal to tangent squared x. We also know that tangent squared x is really sine over cosine. Secant x is 1 over cosine. So we'll have 2 over cosine of x. Get some space here. 2 over cosine x for 2 secant x. And sine squared x over cosine squared x. Now, because we're dividing by a fraction, this is really going to look like this. We're going to multiply by the reciprocal of the denominator. The first cosine will cancel with one of these. And I'll be left with 2 cosine of x over sine squared x. But we want 2 cotangent of x times cosecant. Well, this is where our algebraic manipulations come in. We can make this 2 times cosine of x over sine of x times 1 over sine of x. If you multiply all those fractions together, you would get 2 cotangent x cosecant of x, which is what we need to strive for. Now, in example B, example 3b, we have 1 over 1 plus sine of x plus 1 over 1 minus sine of x. We need to see if it's going to equal secant of x plus tangent of x or 2 secant squared of x. So we're going to take out a calculator here. 1 divided by 1 plus sine of x plus 1 divided by 1 minus sine of x. Let's see which one it's going to be. Secant is really 1 divided by cosine of x plus tangent of x. Make it bold so we can tell if it's going to match or not. Here's our first equation. Well, we can see that it's not going to match. So let's try option 2. 2, 1 divided by cosine of x squared. As you can see, the graphs match, so that means 2 secant squared x is going to be the one we want to get to. So here's our option. When we add these two fractions, we'll have 1 times 1 minus sine of x plus 1 times 1 plus sine of x. All of that over 1 minus sine squared x. When we work on the top, we'll have 1 minus sine of x plus 1 plus sine of x. So really, the signs will cancel. We'll have 2. 1 minus sine squared is really cosine squared x. 2 over cosine squared x, simplified, would be 2 secant squared x. Moving on to example 4 now. We're going to use the algebraic identity a plus b times a minus b is equal to a squared minus b squared. It's going to set up a Pythagorean substitution. Now again, example 4 says cosine of t over 1 minus sine of t is equal to 1 plus sine of t over cosine of t. The left side is more complicated because we have the minus sign in the denominator. So we're going to start with that sign. We'll have cosine of t over 1 minus sine of t. We're going to multiply by a conjugate of the denominator, both to the top and the bottom. When you do that, we'll have cosine of t times 1 plus sine of t over 1 minus sine squared of t. From our previous problem, we know that 1 minus sine squared t is really equal to cosine squared t. The cosine in the numerator cancels one of the cosines in the denominator. We'll be left with 1 over 1 plus sine t over cosine of t, which is exactly what we want. For part B, we're going to do the same thing. The left side looks much more complicated than the right side, so we're going to add the fractions again. So we'll have sine of t, or sine squared t, plus 1 minus cosine squared t. All of that over sine of t times 1 minus cosine of t. Now the trick here is because we want 1 plus cosine of t on top, we're going to change sine squared to 1 minus cosine squared. Now the nice thing about this is I have 2 1 minus cosine squareds on top. I can change the 1 minus cosine squared on top. I can actually change that to 2 times 1 minus cosine t, 1 plus cosine t. Over sine of t times 1 minus cosine t. From our math class before, we can see that the 1 minus cosine t's will cancel out. Now some of you are probably wondering, well, why would I choose that when I know that 1 minus cosine squared is really sine squared? Well, I don't want to use that method only because I have 1 plus cosine t on top. So I need to keep my cosine in there, in the problem. So that's why I chose to change sine squared t. And then in the little disclaimer at the end there, it says, notice that we kept cosine of t times 1 plus sine of t in factored form in the hope that we could eventually eliminate the factor cosine of t and be left with the numerator we need. It's always a good idea to keep an eye on the target expression toward which your proof is aimed. That's the big idea here. Now, general strategies 3. Use the algebraic identity, which is a difference of squares, to set up applications of the Pythagorean identities. Always be mindful of the target expression. You're going to favor manipulations that bring you closer to your goal. Now, I do have some discussion questions here that I need you to answer for me. What is the first step to verify this identity? And what is the first step to verify this identity? That'll do it for today. We'll pick this up with example 5 tomorrow.